Alright, hey guys, I'm recording a video for you for section 9.7, the last section, I promise, on chapter 9 on symmetry. What we are going to, we went over this lesson. I did it virtually in Microsoft Teams. However, I told you I would give you a video as well, okay, so you can reference back. So, should be a pretty short lesson though, so let's get started. So, we're dealing with symmetry because a lot of our shapes that we deal with when we're doing rotations and transformations and such have what we have symmetry. Okay, we have three different types of symmetry: line symmetry, point symmetry, and rotational symmetry. So let's get started. A figure has line symmetry if the figure can be mapped onto itself by a reflection in a line. Essentially, if I can draw a line down the middle of it somewhere, okay, and it's symmetric on either side, then it's has line symmetry. So for an example, I look at this one, this shape right here. I draw a line right down the middle. It's the same thing, just like flipped over that line. Okay, it has line symmetry. A lot of this is the most common type of symmetry we might have seen before. Okay. Next type of symmetry is what we call point symmetry. Figure has point symmetry if the figure can be mapped onto itself by rotating the figure 180 degrees around about a center point. Okay, so meaning it looks the same upside down. So if you turn your paper upside down and the figure looks exactly the same, then then it has point symmetry. Okay, like watch, I can actually flip this paper around twice, and wow, oh shoot. The letter N looks exactly the same as it did before. Oh, awesome. So I'm going to flip this back. And we're back to where we want. Okay, so the N has point symmetry. To check that one, you just rotate it around. Like turn your paper upside down, see if it looks the same. Okay, next, rotational symmetry. A figure has rotational symmetry if the figure can be mapped onto itself by rotating the figure less than 360 degrees around a center point. What that's basically saying is that, what that basically says is that so I'm turning my figure around, if I get to some point that it looks the same before, like, so if I'm rotating my figure, okay, and it looks the same at some point before 360 degree rotation, then yes, so then it has rotational symmetry. Think of a square. If I rotate a square 90 degrees, it looks exactly the same. Okay. Yeah, it wouldn't have any symmetry if any figure, whenever you rotate it 360 degrees, will look exactly the same because you've done a full rotation. Okay, so that's what rotational symmetry is. All right. It says determine if the figures have line, point, and or rotational symmetry. Check all that apply. We should go through these pretty quickly. Okay, first off, definitely has line symmetry. There's a bunch of different lines we can draw, like symmetric about that line for sure. So you just need to find one. You don't need to tell me how many it has. Okay, it has line symmetry. Yes, cool. Point symmetry. Remember, if I rotate my paper, if I turn my paper upside down, does it look the same? It does. If it has point symmetry, it's automatically going to have rotational symmetry. If you think about it, okay, you're doing a 180 degree rotation whenever you flip your paper. So if it looks the same upside down, meaning it has rotational symmetry at 180 degrees. So just know that if it has point symmetry, it has to have rotational symmetry. However, because point symmetry is just a specific type of rotational symmetry, i.e. 180 degrees. Okay, line symmetry, yes. Point symmetry, no. If I put it upside down, it won't look the same. It does have rotational symmetry. If I turn my paper, I think it's going to be 180 divided by 3. It's going to be 60 degrees if you turn it. It will come exactly the same. So it does have rotational symmetry. So you would think maybe this would be the line for this one, number 3, but obviously not, because they have to match. This would have been over here, but if I flipped that over, they wouldn't line up exactly correct. So not right there. How about like right here? I don't think that works either. Or does it? It's a toughie. Nope, that wouldn't work either, because if I flip that over, this is like right here. No, so no line symmetry for that. Point symmetry, turn the paper upside down. Yep, that works. So if it has point, it has rotational. Let's see this one. I don't see any line symmetry here. Okay. Point symmetry. It does not look the same 180 degrees around. And I'm rotating my paper now. I don't see any rotational symmetry either. So this is a none. This has line symmetry. It does not have point symmetry because if I turn my paper upside down, the point is not there's not a point at the top. However, if I start going to the right a little bit, if I rotate my paper to the right a little bit, I see that it's going to end up showing that it does have some rotational symmetry, just not point symmetry. No line symmetry here. There is point symmetry. That means there has to be rotational symmetry. Line symmetry, not point symmetry, and not rotational symmetry, just line. Nope, no line symmetry. I don't believe. I don't think it has anything. I think it's a none. No line here, but definitely going to be rotational, right? I mean point for sure. Definitely rotational. I know that for sure. And then yes, it looks like it's going to be point symmetry as well. Okay. Line symmetry. Point symmetry. Upside down it looks the same, and so rotational symmetry. I would say none. R is a very unusual shape. Line symmetry. Yep. Not point, because you see that this like is a little bit fatter than the top part. So no point symmetry, and then I don't think it has rotational either. So just line. We got some line symmetry here. No point symmetry, but there is rotational. Because if I turn it upside down, it's not the same. But if I turn it not all the way upside down, it'll have some rotational symmetry. Line, no. Point, yes. And then rotational, yes. Line, point, and rotational. So this one, it's not going to have line symmetry. Or will it? No, it won't. Point symmetry, yes, turn that upside down. If you study the picture pretty carefully, you can tell it's the same on top and bottom. Here, look, you think it might have line symmetry here, but no, that does not match up to that. Like, it has its diagonal like this. So, it's point and rotational. Oh, goodness gracious, nothing here, I don't think. This has line symmetry right there. It's point symmetry and rotational. No line here. It looks like the same thing around, but you know, there's nothing that you can fold it over. It is going to rotate, just not point well as well. Okay, it's going to rotate, have rotational symmetry. Ooh, snowflakes are wonderful. They're very symmetrical. They have the line, they have point, and they have rotational in this case. And there you go. That's the lesson, guys. Just kind of getting used to seeing those things. I couldn't really show it very well on a video because you can't. Excuse me, I can't turn my paper, but you get the gist of the lesson. Okay, it's a short lesson. Your homework is on the next page. You should have got that in class, and it's posted on Canvas as well, guys. Have a great day. and thanks for watching.